All right, we're moving on to areas of sectors and segments of circles. A sector of a circle is the space between two radii. So if you draw two radii, the space between them is called a sector, so like a slice of pizza. Technically, the white part is also a sector. That's the space between two radii. Usually, they're specified by shading one or the other. Sometimes they're specified by giving the arc measure or the angle measure of the sector. And those will always be the same, remember, because a central angle, where's the vertex, it's at the center, measure of the angle equals measure of the arc. But usually it's just shaded. So that's a sector, space between two radii. And a segment of a circle is the space between a chord and the circle. So this shaded region is a segment of the circle. But technically, that white space is also a segment of the circle. It is the space between that chord and that part of the circle. But once again, it's usually distinguished by shading whichever one is the area of focus. So our job is to learn how to get the areas of pieces that look like this or like this. So here we go. Let's just, if we can get a shot of just that first one. So there is a sector of a circle, and I want to get the area. Well, let's start with something we already know how to do. Area of the whole circle, I can do that. Area of a whole circle, pi r squared. Radius of 8, so 64 pi centimeters squared. I'll put my units on when I get my final answer. So that's the area of the whole circle, but I don't want the whole circle, I only want the sector. Well, the area of that sector is just going to be a fraction of the circle. So ask yourself, what fraction? Is it 2/3? Is it 1/4? Is it 1/2? Is it 3/8? The fraction that is shaded is exactly 45 out of 360. So I want that fraction of this area. That fraction simplifies to be 1/8. So I want 1/8 of 64 pi. So 1 times 64 pi is 64 pi. Denominators, 8 times 1 is 8. And that simplifies to be 8 pi centimeters squared. So that's the answer, 8 pi centimeters squared. Of course, if it said to round off your answer, then I wouldn't even bother doing the simplifying. I would just type this into my calculator and round it off. And that's going to be the same thing as typing this into a calculator. But exact answer would be that. So that's all you need to do for sectors, is get the area of the whole circle and multiply by the appropriate fraction. How many degrees out of the 360? Let's move on to the more interesting segments of circles. Number 2. So how do we get the area of that funny looking thing? Speaking of funny looking things, my sister called me this morning, but that's another story. So let's do our strategy for playing around with circles. Drawing convenient radii. It does tell me how long the radius is. It's a length of 4, so I'm going to draw a radius of 4. And I can think of another convenient radius. All right, well, I do know this is a right angle. Central angle measures the same as the arc. And I do know from the problem we just did how to get the area of this. If this were a slice of pizza, I know how to do that. That's a sector of the circle in red. And it stands to reason if I can get the area of that red sector, all I have to do is subtract the triangle out of it, and I'll be left with the thing I need, the segment. So here's what we do. Here's the work. First, I get the area of the circle. Area of the whole circle would be pi r squared, 16 pi. And again, I'll put my units on my final answer. Then I get the area of the sector. The sector is the part in red. If this entire thing were shaded, that would be 90 out of 360 times my area. a fraction of the area. And of course that fraction is 1/4, so it would be 1/4 of the area. And 1/4 of 16 pi is 4 pi. So the area of the red region is 4 pi. But I don't want everything in the red region. I got to take that triangle out. So now I have to get the area of that triangle. That, conveniently enough, is a right triangle. So I can just do 1/2 base height. The base is 4, the height is 4. So the area of that triangle is 8. So if I combine these two answers, I can get the area of the segment. The area of that segment, the shaded piece, is always going to be the sector minus the unshaded triangle. So the sector was 4 pi minus the triangle, which was 8. And since this is my final answer, I should be saying 4 pi meters squared minus 8 meters squared, or we can do this. We can say it's this entire number in meters squared. That's the answer to number 2. If it said to round off, I would round off, but it doesn't, so I won't. All right, so I want you to try number 3 on your own, and there's one more coming after this. Here's number 3. You can get a nice tight shot. And hit the pause button. And I'll show you how I'm doing it. Let's see how you did. So we start with saying I can get the area of the whole circle. Pi r squared, radius 4. So once again, 16 pi. Now I'm going to draw my convenient radii. All right, so these are my convenient radii. I know they are each a length of 4. So I can get the area of the sector. We did that on problem 1, we did that on problem 2, we do it again. The sector is just a fraction of the whole circle. So if this entire red slice were all shaded, that would be a fraction of the area. The fraction would be 60 degrees out of 360 of the area. That fraction simplifies to be 1/6. So I want 1/6 of 16 pi. So if I multiply across the numerators, I get 16 pi. And I multiply my denominators, I get 6. Again, I know I might be going fast for some of you, but that's why I want you to pause and think about it and rewind if you need to. So I'm just multiplying my fraction times my area. 16 pi over 6, or I simplify 8 pi over 3. So this is the region in red. On my picture, the red portion is 8 pi over 3. But I don't want all of that. That triangle needs to come out. So we got to think about the triangle. Now, I can't do 1/2 base height with a base of 4 and a height of 4 because these are not perpendicular to each other. This is a 60-degree angle, not a 90-degree angle. So let's think here. Well, it's isosceles. So that means that these two angles have to be congruent. Oh, that works out nicely. They would each have to be 60 degrees. Oh, this is an equilateral triangle. We can do everybody's favorite triangle formula. Equilateral, side squared root 3 over 4. Not in your book. Your friends in the other classes don't know this formula maybe. 2, 3, 4. Most people don't know this formula. Side squared root 3 over 4. So, side squared root 3 over 4. 16 root 3 over 4. So that's going to be 4 root 3. That's the triangle. And the shaded segment is therefore going to be the red portion, 8 pi over 3, minus the triangle, 4 root 3 meters squared. Sector minus triangle. So it's really a 4-step process. First you get the circle, then you get the sector, then you get the triangle, and you finally subtract the triangle from the sector. Here's your last one. What is the area of that shaded region if if this is a 120-degree arc. So get a shot, hit the pause button. I really hope you'll try this before you just watch it. It'll make the homework easier if you try it yourself first. All right. So here's my work. It's all written out. My videographer is excited. Area of the circle, well, pi r squared, 16 pi. When I add my convenient radii, I create a sector of the circle. This sector, well, that's a 120-degree angle, so 120 out of 360. That's the fraction of the area that I want. That simplifies to 1/3. So 1/3 of 16 pi comes out to be 16 pi over 3. Denominators are 3 times 1, 3. Now that triangle needs to come out. So this is the part that might have caused some difficulty for some of us. Let's see. Radius is 4. Radius is 4. This is not an equilateral. This is not a right triangle. So I'm kind of stuck here. What do I know about this triangle? Well, it is isosceles again. So I know these angles each have to be 30. And then might have taken a moment or two of just kind of staring at this to realize, oh, if I draw a height here, and that's 90 degrees and that's 30 degrees, then this is 60 degrees. And if that's 30 and that's 90, this is 60 degrees. There's my total of 120, but 60 and 60. Special right triangles. If only somebody said how important these would be. 30, 60, 90, hypotenuse 4, short leg 2. Short leg 2, long leg is 2 root 3. And if that's 2 root 3 and that's 2 root 3, that's 4 root 3. So I can get this triangle with 1/2 base height. The base is 4 root 3 and the height is 2. That's where I got these numbers. 1/2 base height. So half times 4 is 2. 2 root 3 times 2 is 4 root 3. So if I do sector minus triangle, here's my answer. So you've got 4 beautifully explained examples to help you with your homework. Have fun.